Oh, I quickly do a quick review on what we had in the previous sessions. In this unit, we learn about PII, personally identifiable information, the importance of those information. We saw how malicious guys are able to use different types of sensitive information for different purposes. Also, we had a chat about organizational information as well, different types of data that companies, enterprises, and organizations they need to keep their operation. What I'm going to do today, just to have a quick review on what we had in the previous session, specifically talking about some tools that organizations they use. For example, talking about firewalls, IDS systems, IPS systems, that we have a chat about them in the previous session. Let me to quickly go down and see how what we had in the previous class. Quickly going down. That's in this slide, just personal identifiable information for people. As you see, email addresses, phone numbers, IP addresses, biometric data, health information. We already talked about how we are able to protect our personal sensitive information, for example, setting up a strong password, enabling multi-factor authenticator, using encryption, visiting HTTPS websites, avoiding click on malicious links, checking the spelling of websites or links when we want to open them, all of those things. Updating the operating systems, updating the browsers to the latest version, using secure communication channels, confirming the sender when we are not sure if a link or if an email is coming from a legitimate place. That was all different types of security protections that we have for protecting our sensitive information. Let me quickly go down. We also have a chat about the Privacy Act, certain principles of Privacy Act, talking about international acts like GDPR as well, as you see, General Data Protection Regulation. Let me quickly go down. Talking about multi-factor authenticator, I will show you two versions of multi-factor authenticator, digital and physical authenticator. Digital that you are able to install on your phone, like Google Authenticator, Microsoft Authenticator, or it might be a physical authenticator like YubiKeys or secure pass that I show you in the previous sessions. Also using biometrics. So on top of setting up a strong password, using a multi-factor authenticator and biometrics, there are some additional security protections that we can use. Also for setting up a strong password, I'll show you a table that you saw by increasing the length of a password. It makes it harder for the security crackers not only increasing the length of the password, also having uppercase, lowercase, or symbols increase the possibility of guessing your password by brute force attacks. And eventually, it takes more time for the attackers to guess your password by trial and error. So always make sure to choose a unique password, avoid using the same password for multiple accounts, set a long password, avoid personal information like your date of birth, your pet's names, or your phone number in your password. Skip common patterns like 1234, 123456. I show you, I remember that in one of our classes, I show you there are so many resources on the web that you can go and search for example, top 100, top 1000, top 1 million passwords. Always sign out, especially on shared devices. Make sure to sign out from your devices. Be careful when you enter password. In public computers might be secure. Also, if you are using public Wi-Fi's like in shopping center, libraries, or universities, always avoid to log into your bank account or avoid to enter your personal data into websites that you are not 100% sure. It's better to switch to your hotspot instead of using a public Wi-Fi because there are some tools and techniques that attackers are able to capture or intercept your data when you are using a Wi-Fi connection. Let's go down. You can see all of this information about securing your personal information using a strong password, checking your accounts, be cautious with your online presence, updating your systems and softwares and operating system, protecting sensitive information with the encryption that I will go through encryption a little bit more in our tonight class, using multi-factor authentication, securing device with a strong password or pass phrases, as discussed in the previous session, Now we may use passphrases instead of password. A passphrase might be something like a sentence, a combination of multiple words connected to each other. Avoid using the same password across a couple of different accounts, so you all know about this. Data storage locations. Tonight also I will have a very brief chat about cloud. In Cert 4, you will learn more about the cloud services, but in our tonight session also, I will have a very brief chat about cloud environments. Cloud environment obviously might be a little bit more challenging. I will have a chat about hybrid cloud deployments, and you will see that nowadays there are more and more companies that they have part of their resources moved to the cloud infrastructure. So obviously, when you have all of your systems, all of your IT systems or ICT systems in your own company, in your own premises, it might be pretty easier to protect it compared to the situations that you have part of your resources in your own location and part of it is in the cloud. We will also have a chat about shared responsibility in the cloud. So cloud, it's just like that. You're going to go overseas, and for example, when you're overseas for 6 months, 9 months, or 1 year, you want to make some money from your property. So you put all of your furniture and appliances in a storage, and for example, put your property in Airbnb or you can rent it. Those storage facilities are very similar to cloud environment. The same way that when you rent a place in national storage, obviously they have some responsibility to protect data storage, physical security, obviously. You also have some responsibility. For example, if you have a key or if you have a passcode, you need to keep that key or that passcode secure. It's the same things in cloud environments. We call it shared responsibility. There are a couple of different scenarios in the cloud, like software as a system, platform as a system, or infrastructure as a service, sorry, infrastructure as a service, platform as a service, or software as a service. And the level of responsibility might be quite different in each of these deployment models. Firstly, let's have a look on the physical storage security, like hard drives or flash drives. Hard drives, I'm 100% sure that you know what is a flash drive and what is a hard drive. USB flash, probably you all have those USB flash, and you have your music, your files, your photos. They are portable, they are convenient, and you can keep your data almost anywhere with you. Obviously, those USB flash, they may have some vulnerability. One of the most common vulnerabilities of these portable devices is you forget to grab it. For example, you go to office work to print a couple of files, you attach those USB flash drives to those printers, and when you finish your job, you forgot to grab it. Or for example, in your workplace or in the university or any other locations that you use those USB flash drives, it's very important to make sure that you don't forget. Obviously, if you lose it and you have sensitive information or personal information on those USB flash drives, then you are at risk of some security vulnerabilities. Hard drives, pretty similar to USB drives, but obviously they are pretty bigger in their size and they have a larger capacity for storage. Hard drives also pretty similar to USB flash. They may have some vulnerabilities like losing someone getting access to those drives. Some of those hard drives also, there might be prone of shocks. So if they drop, you are at risk of losing your data. I have these cases that my friends or my students, they have sensitive information, valuable information like some contracts or files or photos on those hard drives or flash USBs, and they lost it. So we will talk about the cloud, as I said, at the end of this presentation. Cloud storage, I know that you might be familiar with uh, a storage in the cloud, mainly like Dropbox or OneDrive or Google Drive or iCloud, that we mainly use it for saving your data, your files, your photos, your movies, and etc. You just need to have an account in Google Drive or Dropbox or OneDrive, and it's pretty easy. You just need to have an internet connection and then drag and drop your files or upload them in those cloud storage. Cloud storage is just one type of cloud services that you may have. In Cert 4, if you proceed, you will learn more about different cloud services like cloud computing, like cloud database. I will show you in our tonight session also two main cloud platforms that we may have we may use in our daily life, AWS and Microsoft Azure. I will show you how they look like and what type of services you may have on the cloud and what might be the responsibilities of you when you have your data in a cloud platform. Let's go down. Encryption, I come back to the encryption again. Firstly, let's to have a look on firewalls and IDS IPS systems that we had in the previous session. Let me reshare my screen. I reckon it's in PowerPoint session 2. Yes, it's here. Let me reshare my screen. In the previous class also, when we've been talking about how to secure company or organizational information, we had different solutions. For example, compliance, policies and protocols, and some other things that we discussed in the previous sessions are different technologies that companies are able to protect their sensitive information. And also, one of the items that we discussed was technical tools. So let me open my board to tell you exactly what we had in the previous session. Yes. So for companies, as I explained in the previous class, creating access levels, governance and compliance, securing storage and access control, role-based access control, technical security controls. There are different tools that companies are able to use. It doesn't mean that if you want to have a firewall in your home, you are not able to do that. Yes, you can do. But mainly we have firewalls in big enterprise networks. What was a firewall? If you remember in the previous class, I had a chat about firewall. It's a security guard. It's a security guard that you can put it in the front door. So firewalls are network security tools that we use them to monitor and control our network traffic. If you remember when I was talking about firewalls in the previous session, firewall has a pretty simple logic. It has a list, and in that list, there might be two options: allow or block, permit or deny. And based on these two rules, firewall is able to check all incoming traffic and then compare it to the list that it already created and saved in the memory in the firewall. And based on that, it's able to go and filter the traffic. For the firewall, we can have so many different types of rules based on the IP address of the source, based on the port number, based on the protocol, and firewall is able to compare the incoming traffic. And if you, for example, blocked incoming traffic from a geographic region, or if you block a traffic intending for a wrong port number, firewall is able to go and block it. Firewall, as discussed in the previous session, might be in two different forms. It might be a hardware device, or it might be a software already installed in your computer. I show you in Windows how to get access to Windows firewall, and also I show you some other examples of firewalls like pfSense, which is highly in use in corporate environment. Common types of firewalls, we have next generation firewalls, proxy firewalls, network address translation firewalls, and a stateful multi-layer inspection firewall. If you remember when I was talking about the traditional firewalls, we said that it just have a list. It doesn't have any wisdom. It's not able to learn. It's not dynamic. It's an static list. You can go and update the list or the firewall rule list if you wish, but by itself, the firewall doesn't have any capacity to learn and to improve its decision-making process. Also, in the previous session, I had a brief chat about false positive. As discussed, majority of these security tools, they are not 100% correct, they are not 100% precise. Sometimes they may block a good traffic. Sometimes they may allow a malicious traffic. So they have a false rate. And usually the security team and the cyber team, they try to improve the correctness of the decisions in the firewall just by using AI or tuning the process. It's called tuning. Tuning a firewall means to improving the firewall rules. So it has 100% or pretty close to 100% correct decisions. Next generation firewalls are pretty different with the traditional firewalls, and the difference is they are able to learn. So not only they check the shape of a packet in terms of its IP port or protocol, but also they are able to go and check the behavior of a packet. So a packet might be good. For example, imagine that you receive a parcel. The parcel looks okay. It seems that it's coming from a legitimate place. It's not a strange size or shape, but inside that package, there might be poison. So next generation firewall, they are able also to have a look inside a packet. Sometimes they forward the packets to an isolated environment that in cybersecurity we call it sandboxing. It might be a virtual machine or it might be a fully isolated systems. So sometimes we forward the traffic to a fully isolated environment just to see how a packet behaves instead of running the packets in a real environment, which may impact our networks or our sensitive data in our servers. Or we send the traffic in fully isolated environments. Next generation firewalls are able not only to check the shape of a packet, but also they are able to go and analyze the behavior of a packet. As discussed, a packet may looks okay, it may looks fine, but when it reaches to a target system, then it tries to go modify some configuration settings. It may go to task automator to create some automations. It may go to Windows registry. It may create, for example, an outbound channel to send data to a remote server. So all of those behaviors are red flags, and next generation firewalls are able to detect those type of packets. Proxy servers also, they are pretty common in our networks. Instead of sending the traffic directly to a server, we may have another server sitting in front of that server. So as a user, as a client, we cannot notice that there is a server at the back of that proxy, but the proxy is something sits on the front of a server in heaps of the time, and it works as a firewall. It's able to go and analyze the data before allowing the traffic to come to our network. Let's move on. A stateful, if you want to know what is a stateful and a stateless, we have two types of firewalls. A stateless firewalls, it's just like fish. We know that fish, they don't have a memory or they have a short memory. Firewalls also are the same. Firewalls are like guards. If they are stateful, it means that they remember. Imagine that there is a security guard standing at a gate, and they remember that, for example, in the morning who entered to the building and who went out. Or we may have a security guard that they don't remember anything. So stateful firewalls, they can remember the previous transactions, the previous traffic, the previous connections. If, for example, an IP is trying to send multiple packets in a pretty short time, the firewall is able to remember it. And obviously, compared to an stateless firewall, they have a higher level of security. Here in this next slide, you can see on the left that we have external networks. For example, it might be WAN, wide area network. It might be, let's say, public internet. And then we have firewalls exactly sitting in front of our internal network. So we have internal network sitting on the right and external network sitting on the left. Internal network might be your home network. In networking, you name it Soho, small office, home office network. It might be a grocery shop network, or it might be a campus. They all are different types of internal networks. In the left side, we have external. So firewall is able to control and inspect all the packets. As you see from an external network, data has been sent to our internal network, and the firewall is able to go and inspect the data. And based on that rule, it allow or block based on some rules. Firewalls by default, they don't have any rules, so it's you that you need to set and you need to define the rules, which type of traffic you want to allow, which type of traffic you don't want to allow. And as I explained in the previous session, a server might be a general server providing all services, or it might be a dedicated server only designed to serve a website or only designed to be a mail server or a file server. And we know that for each service, the server needs to use some ports and protocols. So you can limit down, you can close all the other doors and just keep some essential doors and obviously protecting those doors in a stricted way. Firewalls not only are able to check the incoming traffic, but also you are able to set some rules for outgoing traffic as well. In the previous session, I gave you some reason why we may have a firewall for outbound traffic. A possible, for example, an insider, like for example, a grumpy or not happy staff, they try to get access to unauthorized services. It might be, for example, someone from our internal network, they try to originate some type of attacks or some type of cyber malicious activities. So we want to block those type of packets. So obviously, by having an outbound traffic, we are able to control our traffic going outside. Cool. Let's move on. When we are using firewalls, it's always important again to make sure that it's up to date. So I stay protected against new threats. The reason is a firewall is static. The same way that you do, for example, a flu vaccine every year, like just to protect your to improve your immunity system, to protect against the latest shapes of viruses. It's the same for firewalls. Firewalls constantly, they need to get updated. They have a database, and that database get updated by firewall provider. And when you have a pretty old firewall in your system, it means that there might be some type of viruses that they are able to pass through the firewall. Always make sure that the firewall is to the latest version. Using antiviruses in the previous session also, I explained. If you are using malicious websites or if you're visiting so many different types of websites, it's good and recommended to have an antivirus. And those antiviruses also, they use a database. We call this signature-based firewalls. Signature means they have a database. That database get updated by the provider. And when you update your firewall, it can go and get the latest news. It can go and get the latest data. Optimize firewall rules. There are so many resources when you want to set up firewall rules, insert for in cybersecurity or insert for in IT. If you press it, you will learn how to set up rules in a firewall. Starting, for example, from specific rules, going down to more general rules and etc. Also, if you proceed to networking in it, you will learn about access control, standard access control, and extended access control. Specifically in Cisco devices, you may use extended or standard access control lists, and it's very important to know about the importance of priority. When you're dealing with the firewalls, they have a pretty simple logic. If you remember in a Python programming, Python was an interpreter based. It means that it goes to the top and execute line by line from the first line going to the second line to the third line. So it's execute each line from the top all the way down to the bottom. It's the same things in firewalls. So when you have a firewall and you have multiple rules, firewall simply goes and execute those rules from the top. So it's very important also to know the order. The order is so important. In my Python programming class, if you remember, I had a code to write a game. The game was um, Fizzbuzz game, if you remember. Especially the same. In Fizzbuzz game, you saw that the importance of division by 3 or division by 5 and division by 15 was important. The same things in firewall. We need to make sure the firewall rules are not conflicting to each other, and also we need to test it and make sure that the firewall rules are optimized. So regularly check your firewalls to make sure that they are efficient. For example, remove unused rules to reduce risk, and check regularly your firewall settings to make sure that it meets with the organizational and legal requirements. There are some professional bodies on the board that they can help us. They provide some guidelines when we want to set up rules for our firewalls. We can follow their recommendations. The other things that we discussed in the previous class was IDS and IPS, intrusion detection system and intrusion prevention systems. IDS, as discussed, it's like a CCTV camera. It's like a motion camera. The same way that there is a motion, your CCTV camera in your home that starts recording and filming the events. Intrusion detection systems also, they can alert the security. They are not able to block or intervene or to take any actions. They simply design to raise an alarm when there is an event, when there is Emotion. There are two types of ideas. One might be located in front of a system or a server that we call them host-based intrusion detection system. Like, for example, you have a database, you have a server. That server is very important, or that database keeps the customer data, student data, patient information. So you just need to put an intrusion detection system like a CCTV camera on top of that database. It's host-based and it's just designed to protect that specific database or that specific server. In the other side also, you may have network intrusion detection systems or NIDS. It's not NDIS, it's NIDS. So they monitor the traffic across the entire network to detect external threats. Just like, for example, police cops or police guys that they patrol across the city just to make sure everything is fine. So NIDS or network intrusion, they control the traffic across the network. Host-based, they just check one specific host, which might be a database or it might be a server. So as discussed in the previous session, IDS gets a copy of the traffic. It doesn't cause any interruptions into network. It doesn't slow down the network because it doesn't take any action. It just like an alarm. So it gets a copy of whole network traffic or whole host traffic, and then it can get connected to some other security things. And if there is any problem or issue, it's able to send some alerts, like sending an email or some alerts or a phone call to the security team just to let them know that something happened. But it's possible that we need to have devices that they automatically are able to take some actions. For example, on a Saturday or Sunday, if we just have an idea system and it creates an alarm if there is no one to take some actions. So it might be too late on a Monday morning to go and see what happened. We need to have some automation in our systems so they can take actions by themselves. Here you see again ideas like firewalls. They sit somewhere between the external network and our internal network. So we have network traffic. It gets a copy, goes to the IDS. IDS is able to check, and if there is any malicious activity or if there is a malicious traffic, it's able to alert. Intrusion detection systems, as you see, they are signature-based, recognize and stop threats by matching them to a list of known harmful patterns, very similar to firewalls. For example, an spam filter can block emails that match a database of flag words or phrases. Or in a similar ways, IDS can block non-harmful files or attacks. Obviously, these signature-based firewalls or signature-based ideas, they're prone to zero-day attack. What is a zero-day attack? A zero-day attack is a type of attack that these systems, they have no idea about it. It's the first time that they experience, they see such a traffic and they don't know how to behave. Pretty similar to COVID. So when COVID spread across the world, it took a couple of months so all the labs can create a vaccine for it. But so many people, they lost their lives. It's pretty the same. If there is a new attack that we name it zero day attacks, it means that it's the first time we see such an attack. It's the first time that we see such a packet. So this signature base, they are not able to stop it. And the reason is pretty obvious because there is nothing that they can compare those traffics and then decide to block or allow it. Anomaly based ideas also, they watch for unusual behavior. What is unusual behavior? They have a pattern and they are able to train during the time and they understand what is the pattern and what is usual, what is unusual. Imagine, for example, in education sector, in December, let's just say mid-December till end of January, it's the Christmas time, so all the schools are closed down, universities are closed down. So students are away, heaps of staffs are away. Usually education sector experience a pretty quiet time, mid-December till end of January. And again from February when the students, staff, they are back to work, they have a spike in the traffic. It's completely opposite to retail. Retail, they have a very, very high traffic in December. I started from Black Friday in November till Boxing Day, and so they experience a high demand. Hospitality, the same. Retail in December, January, they have a high traffic. But when it goes to February, March, it might be a little bit quiet. That's the pattern. It's the same things in network. For example, a website like Netflix, probably they have a higher traffic on Friday nights or Saturday nights or Sunday or weekends or public holidays. There might be more traffic coming through in that time. For heaps of companies that they work day hours from 9 to 5, probably they have the usual traffic from 9 o'clock, 8 o'clock in the morning till 5:30, 6, 6:30, Monday to Friday. On weekends or public holidays, they are closed down. So imagine for such a business that they work Monday to Friday, 9 to 5 or 9 to 5:30. If all of a sudden on a Saturday night after midnight, there are 200 requests to get access to a database in 1 minute, it's something unusual. If, for example, on a Sunday early morning, someone is trying to download 10 gigabyte of data, it's not something usual. I don't want to say that it should be a definite attack, but it's not something usual. It means that it needs investigation. I gave you some example, like for example, having one of your neighbor moving their homes and it's like 1 o'clock after midnight. You see that there is a truck standing in the front door and they put the furniture in that truck. So it's not something usual. We call this anomalies. These idea systems, they are able to learn and detect if there might be any unusual behavior. For instance, if an employee's account typically accessed from Australia is suddenly used from another country to download files, it might be suspicious or unusual behavior. If you are turning on a VPN on your phone or your computer, VPNs, they change the traffic. So, for example, I logged into VU Collaborate 10 minutes ago. Then I turn on my firewall. So I changed my IP address. It seems that I log in from Sweden. I'm logging from UK. So those security systems are able to block or detect it as a suspicious or unusual behavior. There are so many different types of unusual or anomalies behavior, like for example, traffic is coming from a unknown IP addresses. It might be downloading a file, it might be sending some sensitive data, attaching data to an email and trying to send it out. Later on, if you go to cyber security courses, you will learn about data loss protection or DLP. And there are systems that they can detect if an employee, for example, is copying and pasting heaps of data into their email, or for example, sensitive information, they try to take a screenshot or they try to copy and paste it into their emails. The systems are able to detect it and inform the security team. They all are different types of anomaly. Obviously, there might be a legitimate staff as well. For example, a manager is not able, for example, to sleep. It's Saturday after midnight and he tries to log in to do some work because on Monday morning he wants to be ready. So it's possible that the traffic is okay, but these systems are able to investigate it or create a red flag. Cool. So that was about the IDS and IBS system. Differences between IDS and IPS is and intrusion protection system are able to take actions, they are able to block the traffic. And as I explained in the previous session, if you ask why we may use IDS when they are not able to take any action, is IPS systems or intrusion prevention systems, they create congestion in our network. It's like, for example, having a couple of planes landing in the airport in the same time or in a short time, and all the luggage and all the passengers they need to individually checked. So you see that there are lines of customers waiting for the passport to be checked or for the luggage to be checked. So it takes time. It may create congestion or it may slow down the traffic in the network. It needs processing power. So sometimes it's better to use intrusion detection system over intrusion prevention systems because intrusion preventions, they are in the line. Detection systems, they are offline. They just take a copy of the data without impacting the traffic. Prevention systems, they are inline. So they are able to block the line. Or if they want to investigate and analyze and inspect all the traffic, it may take time and it may cause congestion. Cool. So that was all that we discussed in the previous session. Let you go down. Let me have a look on the agenda for today. And I need to have a chat about the encryption. We had a brief chat about encryption in the previous session. For today, let me see what else we have. Yes, encryption. Cool. Let me go back to the previous session and have a chat about encryption also. One of the other tools that we discussed in the previous session on top of firewall, IDS, and IPS was encryption. Encryption simply was scrambling data, changing a plain text to a form which is not readable. Let me reshare my screen and learn a little bit more about encryption. Sharing my screen. Cool. In the previous session, we had a chat about encryption. What was encryption? Encryption was a technique that we can use to scramble data, not leaving it in a plain text. Scrambling information so only authorized people they can read it. I have some examples in the previous session, keeping the username and a password in a plain text, which is easily readable. So even someone can get access to a database by some way. They are able to go and read all the username and password. As discussed, it was the case of Optus. Instead of leaving the data in the plain text, we can use some tools or technologies and scramble the data in a way, shuffling the data in a way which is not readable for everyone, using a key or using a secret. Changing a plain text to something not readable means encryption, and returning that encrypted value to its original format, it's decryption. Encryption and decryption. Here in this slide, you see that encryptions, they have different forms. As discussed, different forms means that they have different lengths of a key. I gave you an analogy like having a combination lock or having a suitcase with only 2 digits. So if you forgot the code, you just need to try from 00 all the way down to 99 to find the code. Increase the 2 digit to 3 digits, which means that you need to check 1,000 different options. 4 digit means that you need to check 10K of different options. So when you increase the length of a key or the length of a password, it takes more time to guess the code by trial and error or by brute forcing. That's the case for majority of the encryptions. The older versions, they have some vulnerability. It means that by trial and error, the attackers eventually they manage to guess the code. DES, data encryption standards, it's developed in the 1970 and was the standard for early encryption. As I explained in the previous session, encryption goes to World War II when the army or the soldiers they wanted to communicate with each other or communicate with their commanders, and they had the communication sniffed. So they've been thinking to find a solution to change their plain text to something which is not readable. So even if the enemy can get access to that data, it's not meaningful. The early encryption models, as you see, DS encrypts 56 bits of data at a time, but it's no longer considered secure. So when it says 56 bits, it means, or you can imagine that it has 56 options or 56 characters. So it's easily hacked, but it served as the foundation for more secure encryption methods. When we are talking about a stronger or more secure encryption, simply it means that it used a more complex mathematical approach, or it has a lengthier or bigger key instead of using 56 bits, using, for example, 512 bits. It's like having a combination lock with only 3 digits or having a combination lock with 128 digits. So when you have a combination lock with 128 digits, it takes ages. If someone just go and buy Terraland or they try to guess the code or find the code. So maybe you ask why we may use a shorter key when we know that a longer key is more secure. And the answer is on processing power. So when you want to convert a plain text to a ciphertext, and if you have a very long key like 128 or 258, 56 bits, so when you want to convert the plain text to an encrypted text, it takes computing power. CPU, RAM, they have to work harder to encrypt your communication. So imagine in a big business, in a university, in a company, in an organization with hundreds of devices, with hundreds of staffs, they have billions of packets of information every day. If they want to go and encrypt every single packet, when they generate tons of data every day, if they switch to a longer code or using a longer secret or key, it takes more processing power. They need to have a stronger servers, they need to deploy more CPUs, more RAMs. It impacts the network bandwidth. So it's a balance here. And that's always the case in cybersecurity. We always need to sacrifice something. We need to find the optimum point. There is always these imbalances that we need to make a decision and sacrifice something. So obviously when you want to go using more secure tools or more secure encryption keys, then it has a cost. And the cost is the processing power, it's the electricity that you need, more servers. If you want to sacrifice that, then you need to accept a little bit of risk. So 3DS, it's triple data encryption standards. So it has some improvement over the DS. The first version of encryption was DS, AES, DES, and triple DES. So the difference between 3DS or triple data encryption standard, it use three 56-byte keys. In the DS, it has 156 bits of data to encrypt data, but in the triple, it has three. So it's just like having 3 times 56, which is 168 bits. And it's pretty obvious. As I said, it's just like having a combination lock with 56 digits or having a combination lock with 168 digits. So which one is stronger? The one with 168, because it has more keys, it takes more time just to go by trial and error to guess the code. So triple DS, it offers a stronger security, but also it takes longer to encrypt data. That's the things that I mentioned. It takes more time, it takes more processing power. So which one is preferred? Obviously triple preferred over the DS because it has a bigger key, but it takes more time to encrypt and also it takes more time to decrypt. So in the both side, we need to consider this as well. Obviously, if we are dealing with highly sensitive or nationally sensitive information, using a very, very secure encryption is preferable. But if you just want to protect our data, but we don't want to make it too much complex, just using 128-bit encryption algorithm should be enough, comparing, for example, using a 256 or 512 bits. Still, the triple data encryption standards not in use anymore, and we are using more advanced encryptions like RSA. If you want to know about these encryptions and how they work, I have a video and I show you, but they use a very, very complex mathematic approach. As you see in this slide, AES standing for Advanced Encryption. It's one of the earliest encryption types. It's used by the government, security organizations, and businesses for secure communication. It utilizes symmetric key encryption. I go to my board and I explain a little bit about symmetric and asymmetric to see what is the difference between these two. But as you see, how AES works encrypts data in blocks rather than individual bits. So block size might be an AES 128, which encrypts block of 128 bits. So if you want to know what is a bit, I already explained in my class when I was explaining and teaching the programming unit. It's the smallest value in the binary environment, which may be a value of 0, not having electricity shocks or electricity signals, or it might be 1, which means that having electricity or having light in the fiber optic cables. So AES 128, it used 128 bits compared to 192 or 256 bits. Not only that, we have also encryption runs. So AES encryption transform plain text into encrypted data in multiple runs. For example, AES 128-bit, not only it uses a 128-bit secret key, but it used 10 runs of encryption comparing to AES 256, which is using 14 runs of encryption. Technically, you are using encryption in our daily life, as I explained in the previous session, when, for example, you are connecting to your home Wi-Fi convert the plain text to encrypted text. When you're sending or receiving message in your iPhone or in your Android devices, when you're sending a message, it automatically encrypts. Sometimes you see that there is something like a pad-like icon, and when you tap it, it says that now your messages has been encrypted, end-to-end encryption. For example, in WhatsApp or in Samsung devices, you can see RCS something, or it has a pad-like icon, and when you tap and you activate it, it says that now all of your messages are end-to-end encrypted, which means that even the platform provider is not able to read the data. So when I'm sending a message to you and it's end-to-end encrypted, it means the platform provider, like Android devices or iPhone, my message goes to the server, but they are not able to read it because they don't have the key. Why AES is so popular? It's widely used in data tools and applications. It balances a strong security and affordability, making it a trusted option for encryption. There are so many other types of encryption also in reality, which is out of the content of this cert tree. Here we just wanted to know what is encryption, how it works. Let me go to my board and also explain a little bit about symmetric encryption. Let me switch my screen. Mm, okay. So here, that's the topic that we have about encryption, scrambling info, so only authorized people can read it. Instead of leaving a username as Dan and password as Dan1234 exclamation mark, it can convert to something like 9F hash 23 exclamation mark. It has a formula, it's not random, because obviously when we send the data to a destination, the destination device, which might be a server, which might be another client, they need to know the key and they need to retrieve it back to the original format to read it. Cool. Let's to talk about this encryption a little bit more in depth. Okay, so imagine that I have plain text here. It might be a Word file, for example. And what I want to do, I want to encrypt this data to get something like this. To convert this plain text to an encrypted data, which is not readable, as discussed, we need to use a key or a secret or an algorithm. The way that we can convert this plain text to this ciphertext by using encryption, we can use DES, we can use AES, we can use triple DES. They all have their own feature. They have their own secret code. Anyway, imagine that I'm using AES code or AES encryption to convert this plain text to this ciphertext. And I have a key. For example, I have let's just say hello, and it's converted to something like this. So here, hello is the plain text, and question mark 8W exclamation mark 3 is the ciphertext. So if this guy, this person, imagine I'm here, and I'm sending that to Daniel. So Daniel obviously needs to know what is this key. So he's able to return this encrypted data back to the original format. This process encryption, and this process is decryption or decoding, encoding, decoding. In this case that I have a key, imagine that I sent a letter or I send a message to Daniel, and then I give him a phone call and I say, hey, Dan, look, if you want to decode my message or if you want to decode that file, just to let you know, the code or the secret key is, for example, this 56-bit code. So he will use this code and is able to return the data back to the original format. This type of encryption and decryption that we use the same key, we name it symmetric encryption. Symmetric encryption. So it used the same 56-bit key. So I sent my message. I use an encryption algorithm like AES, DES, RSA, or etc. I send it to a destination. Destination might be a person like Dan, that he wants to read my message or he wants to read my email, or it might be a server. Obviously, that user, doesn't matter if it's a person or if it's a server, they need to know the key. And when they have the key, they're able to retrieve the data back to the original format and read it. If the same key is used for encryption and decryption, then we call it symmetrics. But also a possible, as I explained, it use a very complex mathematics. Sometimes the key to encrypt the data is not the key to decrypt the data. They are not the same. It's just like I have my own key and I lock a door. You have your own key, but imagine that there is a lock and that lock works with both my key and your key. So these two keys are connected to each other in some way. I'm talking about my key, which is in green, and your key, which is in yellow. They are in some way are related to each other. So I use my own key to lock, and you're using your own key to unlock. I have a video and I show you that video to make it more meaningful for you. In this case, we are talking about an asymmetric encryption. Or sometimes instead of using and naming it asymmetric, you may see this terminology as well. So this green, you may see public key, and the green one you may see in some context as private key. So I have a public key, I have a key that I'm able to lock the data, and then your key in its shape, it's relevant and it's dependent to my key as a public key, but it's private, it's just for you. And you're able to open your key as well. It's just like you get a parcel from the post and you are not home. So they take it back to the post office and they put it in a locker. So obviously they have access to all the lockers. They put it in, for example, locker number 25. And when you arrive, you have your own key as well. You got that key in your phone, for example, by an email or by a message. So when you go to that post office, you enter your phone number. It tells you that just go and pick your item from locker number 24. And then it asks you to put down your date of birth or put down your phone number. And then locker number 25 or 26 opens and then you can grab your parcel. It's pretty similar to public key and private key. So those postie guys, they have access to all lockers, probably by a public key. But when they put it in a locker and they close it, then you go and grab it with your own key, which is your phone number or which is your date of birth, and it's unique to you. It's only you that you have that phone number. So you need to enter your phone number or your date of birth, and then you have your parcel. Pretty similar. It's pretty similar to public key, private key, and asymmetric. Cool. What else? Let me see if I have that video about encryption and decryption. And the next topic that I want to have a quick chat is talking about cloud and data classification. I'll show you the video at the end. Let me go to the next presentation. Let me stop sharing this and open presentation number 3. Okay. Cool. I already have a chat about access control in a firewall, but here in this next presentation, which is presentation number 3, let's do a quick review on what we have about role-based access control. If you remember in our previous sessions, I was talking about a domain. Tomorrow in our assessment task 2, we go to a Windows server and we log into an Active Directory. We create a user. We see how we are able to give full permission to a user. Also, we had a chat about role-based access control, as discussed. Role-based access control means that it doesn't matter what is the person name or what is the location. It's their role that gives them the right permission or access. Here in this presentation, you understand about the access control. Access control, it ensures only authorized personnel can access sensitive information with using some type of verifications, like having an ID card, like by biometrics, and etc. And based on the position, based on the job descriptions, they have access to files, folders, and systems. Even if you remember, we had a chat about least privilege principle. Based on least privilege principle, as discussed, users in a system, they don't have access to anything by default. But based on the job requirements, they may get granted access to files, folders into their own department. If they relocate to another department, if they get promoted, obviously they will have more and more access, or they will change their access from one department to another department. Discretionary access control. So data owners manage permissions, for example, granting team leaders access to specific project files. Tomorrow in our assessment task 2, as an admin, we create a new user and then we are able to grant full access or just read access to a user. Mandatory access controls, there are central authorities control access based on classifications, like restricting highly confident reports only to the managers or only to senior staffs. Role-based access control, it's designed and it's created based on the roles. For example, as an HR staff, they have access to some systems. As an IT staff, you may have access to some resources. If you work in retail, you may have access to the safe, you may have access to the um, tills, you may have access to rostering software, you may have access to click and collect softwares, you may have access to warehouse softwares, and all of those things. Role-based access control. It doesn't matter who are you, based on your job description and based on your position, you will automatically inherit some access. Attribute-based access control. It depends on the attributes, like limiting remote access only to approved devices or locations. Let me to quickly go down here. I just leave it for you to read it. In this next slide, it shows you some examples of access control. Secure and effective access control in IT settings. For example, you see for multi-factor authenticator, use two or more verification methods. Again, in our tomorrow class, when we are creating a new user, we see that we have a couple of options, like setting up a strong password, forcing the user to change their password after the first login, forcing the user to change their password after 60 days or 90 days or 180 days, forcing the users to use uppercase or lowercase in their passwords, all of those things, forcing the users to connect a multi-factor authenticator to your account. They all are different types of access control. The same way that when you go, for example, to a hotel, imagine that you book a room and you go to a hotel and you get a card to open the door. So that card only opens your own room door. If you tap that card to any other room, it doesn't work. But the cleaning staff, they have the similar card, but their card has more access. They are able to go open the staff room, they are able to go open all the other rooms in a hotel as well. Imagine with your SIP card, if you work in a company or if you work in a warehouse, imagine with your ID card, with your staff card, what type of access you have. Are you able to open all the doors? Are you able to, for example, use the same card when you go to another branch, when you go to another warehouse, or no? Pretty similar in ICT and in IT settings, access controls are defined. What type of data, what type of software you have access, and also not only having access, what you can do. For example, I may have access, but I'm able only to read a document. I'm not able to delete it. I'm not able to modify it. I'm not able to install a file. I'm not able to, for example, plug a USB. All of those things, they all defined by the access control. Windows Server backup. So we will do this in our tomorrow session. That's a good activity because we will see that firstly, we need to give our administrators a backup access. Then we are able to create a backup of our Windows server. So we do this in our tomorrow class as well. Let's to see what else. And presentation number 4. So technically we covered all of these. Let's have a look on this presentation. Yeah, we covered that one as well. Okay, so presentation 1, 2, and 3, they almost done. The next thing that I want to have a quick chat tonight is talking about cloud security. Let me go back to my board. Okay, for the last topic tonight, I just want to have a quick chat about cloud services and cloud security. So far we learned about both personal PII and organizational. For each of these two, for personal information and organizational information, we had a comprehensive chat about all different security protections that we are able to use. Imagine now we have cloud. Firstly, I start with personal information. So here, imagine I have a laptop. And this user save all the data in his device, on his laptop or in their desktop PC or in the workstations, all the data save in this device. Cool. So we know to secure this device, physical security is important. I shouldn't leave my device unattended. I need to set multi-factor authenticator. For example, my laptop may support fingerprint. It may um, support face recognition. I enable the face recognition. I enable the fingerprint. I set a strong password for my laptop. Also for my files, they all save on my laptop and I use BitLocker to encrypt my drives or to encrypt my data. Everything looks fine. But because in my laptop I have only 256 gig of storage and I have too much file and I have too much movies, games, and etc., I'm looking for another storage. I was thinking to get a USB flash drive or to get an external hard drive. But the problem is it's not always with me. It's a physical device. I may forget it. So instead, I try to use a cloud platform. Pretty recently, I saw one of my friends is using Dropbox or Google Drive or iCloud and etc. And instead of saving my data directly to my PC, I'm able to save my data on those platforms, and on my device, I'm able to free up a space. So my files, instead of saving on my local PC, it will be saved somewhere in the cloud, like in Dropbox or Google Drive or in iCloud. And whenever I want to get access to my file, I simply go and log into my PC without having those devices taking a space on my local PC. So I want to talk about this cloud platform, how it works. When you are using this cloud storage, obviously you are saving your data in massive data center. I'll show you a video how a data center may look like, but imagine it's Google data center. So what you do when you go and purchase a subscription, for example, you get 2 gig of storage, it means that you are renting 2 gig of storage space in Google Data Center. Exactly the same way as I explained at the beginning of our tonight session. When, for example, you put your furniture, your other stuff in a national storage or in a local storage for 6 months, 9 months, you pay $200, $400, $500 for, I don't know, 20 square meter of space in those storage facilities. You're renting data space. When you're uploading your files in Dropbox or your Google Drive or in iCloud, it means that you are renting 2 gig of space in that data center and you pay $10, $5, $20 per month just to use data space. Obviously, it's not only you that you save or you uploaded your data into that facility. There might be millions of users like Alex, Bob, John, Sarah, Dan, and etc. that they may have an space in data storage as well. So Google Data Center is a public environment. Cool. In this cloud environment, the only thing that I need to have is an internet connection. So this is my home Wi-Fi. I log into my Dropbox. And I save some data. So those data, with the help of internet connection, it goes to my home Wi-Fi. It goes to your ISP service provider, and eventually it's find its way to that data center. And I save my data somewhere here. When I was using only my own laptop, I know that I'm the only person responsible for securing my device. I should set password, I should enable face recognition, I need to look after my device, okay. But what about this scenario? That I have part of my data, like some of my files, contracts, assignments, research, movies, whatever, projects saved in Google Data Center. Is it me that I'm responsible for securing those information, or is it Google? The answer is both. And we name it shared responsibility. So Google says, look, when you put your data in my data center, I'm responsible for the physical security of this data center. It means no one can easily enter my data center facility. It means that I protect this data center against natural disaster, fire, flood, I don't know, earthquake. If something happens to this data center, for example, an earthquake, I have another data center somewhere else in the world. in another location. For example, this data center is in Melbourne. Then I have another one in Auckland. And when you put your data here, automatically I create a backup in another data center as well. So if Melbourne data center impacted by fire, by earthquake, by any natural disaster, electricity outage, internet shutdown for any reason, still I keep your data in another data center. In the cloud unit, we will learn more about this backup or auto backup. It's better to say it's automatically backup data, at least in two or sometimes in three different locations. And we will see those data centers might be at least 100 kilometers away from each other. For example, AWS in Australia, they have a data center in Sydney. It's a started operation almost 10 years ago, more than 10 years ago, 12 years ago. And then they had another data center opened in Melbourne 2 years ago. Now they are opening another data center in Auckland. Microsoft, the same. Now they are opening a data center in Melbourne. It should be in next year, 2026. It might be multiple locations in the country. So if one of those data centers goes down for any reason, cyber attacks, electricity shutdown, outage, internet outage, electricity outage, natural disaster, data center upgrade, data center maintenance, for any reason, it says I'm responsible for all of those things. I'm responsible for physical security. I'm responsible for creating a backups. I'm responsible to assure you that when your data is are in data center, it's always accessible. Amazon Web Service that I'm going to show you, AWS, Amazon Web Service. It says when you save your data in our data center, 6, 7, 8, 9, 10, 11. 11 nines, 99.99999999% reliable. It means that during a year, it might be only 2 or 3 minutes in a year that our data center might be down for any reason, for update, upgrade, maintenance, only 2 minutes a year. Maybe you say 2 minutes is nothing, but for some services, even 1 minute may cost millions of dollars. Not just because of money, it's just because of the chaos impacting the public. Imagine, for example, if airport system, they goes down 5 minutes in a year, specifically in busy airports. So it create chaos. In this situation, the data center owner or the cloud provider is responsible for part of this security, the physical security, infrastructure security, operating system. Obviously, in that data center, there are heaps of servers. Those servers also, they have operating system. It might be Linux. It might be a Windows operating system. Those data centers have millions of CPUs, millions of RAMs. All of those hardware devices also, they may fail. So it's the data center owner or the cloud owner responsibility to update all the hardwares, to upgrade the security protocols, the operating systems. It's the cloud provider responsibility. What about my responsibility? My responsibility here is to keep my credentials. So when I create an account, they give me a username and a password. I need to make sure that that username password is secure. What happens if I know your password, your Dropbox password? What happens if I know your Google Drive or your iCloud password? So iCloud is not responsible for that part. If you fail to keep your credentials, if someone else get access to your credentials, it's not the cloud provider responsibility, it's your responsibility. In the cloud services, there are three different types of deployment. software as service, platform as service, and infrastructure as service. SaaS is like your Gmail. So when you're using your Gmail, you don't need to think about updating the Gmail servers. It's not your responsibility to secure the Gmail server, to update the hardware, to update the software. No, the only things that you need to have just to keep your username, your password, log into Gmail, send and receive email. That's it. So you are using the final product. I'm not responsible for anything else. I just log in and that's it. But in Gmail, you don't have access to the infrastructure. You are not able, for example, to change the underlying operating systems. You are not able to change the settings. You are not able to change the configuration. You don't have access to those things. You just use the final product. On the other side, we may have infrastructure as a service. So, for example, in virtual machines, you may have the hardware, but it's your responsibility to go and install operating system. It might be your responsibility to install security app. In the cloud unit, we will learn more about this shared responsibility. But when you move from software as a service to infrastructure as a service, we will have more responsibility. It's just like you go and order a burger. It's like SaaS. So you go, you order a burger. Obviously, you don't have too much options. They have a menu, you can choose from the menu, but obviously you don't have too much control over the ingredients. You can't tell them that I want to have this type of ingredients in my burger. No, it's ready to go. You just need to put an order and get your burger. Imagine instead of ordering a burger, you go to a supermarket, you purchase meat, you purchase tomato, and etc. And then you bring it to your own kitchen and then you cook it exactly on the way that you want. If you want to add extra salt or if you want to add extra onions, or, it's all up to you. In both of these situations, the final product is a burger, but in the SaaS, I don't engage myself to the problem. I just want to use the final product. In the infrastructure as a service, you have more control and obviously you have more responsibility. So you can, for example, cook a burger exactly with the ingredients, with the cooking time and etc. based on your own taste, but it means that you are more responsible now. You need to spend time for cooking and etc. Platform as a system, it's something in the middle. Like you go and you purchase a semi-ready or pre-cooked burger. Still, you are able to customize it with your own favorite, and it sits somewhere in the middle. I don't want to go too much into this detail. I just want to say when we are using cloud services, it means that both you and the cloud providers are responsible for securing your data. And this level of security and this level of responsibility change based on different types of deployment, if it's a software as a service or if it's an infrastructure as a service. Let me show you both of these two just to give you a bit of more idea. Cool. Screen one. Okay. In set 4, if you proceed to set 4, you will learn about these two platforms. One is Microsoft, as you see, Microsoft Azure. The cloud storage that now you use in Dropbox or iCloud or Google, if you are using, for example, if you're using Google Drive, Google Drive pricing, or OneDrive if you're using OneDrive. You see that they have different plans, for example, getting 2 TB May cost you $15 if you get it from Google, 5 terabyte, 10 terabyte. So that's the data center that you go and rent 2 terabyte of storage or 10 terabyte of storage or more. In that data center, there are huge amount of servers, memories, CPUs, and based on your needs, you can go get 10 terabyte and pay, for example, $74 per month. The same way, Microsoft Azure, they provide so many services on the cloud. So it's not just a storage. Here, this cloud, this Google storage is just a storage. I'm 100% sure that you're all familiar with cloud storage like OneDrive, iCloud, Dropbox, Google Drive. So it's just designed for storage. But cloud services is not just a storage. There might be hundreds of different services. A storage is just one service in cloud platforms designed for storage. But you see that there are so many others like virtual machines. In Microsoft Azure that I already sent you a link, it's a kind of virtual machines. You see that there are so many other services like app services, SQL databases, um, Kubernetes services. You see that there are heaps. They have like Microsoft has more than 150 different services on their cloud for AI and machine learning, analytics, computing, containers, databases, DevOps, general, and etc. So it means that you will create an account in Microsoft Azure environment, and then you are able to, for example, set up a server, a virtual server, not a physical server. Exactly the same way that you have a virtual storage. It's not a physical storage. A physical storage is like this external drive, external hard drive. These external hard drives that you can purchase it from Officeworks, JB Hi-Fi, and etc. It's a physical storage. Here, it's a virtual storage. It's in the cloud. It's not some physical space that you may see it. The same way, you can use Microsoft Azure computing services or analytics services. So you don't need to keep a server to set up your website. You don't need to keep a physical database. You can simply go and get, for example, a database vouchers. As you see, you can get a database services from a cloud providers like Microsoft, AWS also, Amazon Web Service. They have a pretty similar platform. Insert for in cybersecurity, you will learn more about this cloud environment. Again, pretty similar to Microsoft. They have a storage services or S3 in AWS. It's called S3 for storage. They have a wide range of services for storing your data, paying monthly, paying yearly, booking for storage, reserving instances. But also they have EC2 in AWS instead of naming it a virtual machine. Like here, we had virtual machines. Let me go back. Like Microsoft Azure that you use for your assessment task too. It's a virtual machine or virtual box if you are using in your own computer. In AWS, it's named EC2, Elastic Cloud Computing. So you don't need to go and purchase a server. You don't need to go purchase and set up a database. You can simply go and in a few minutes launch a virtual machine in AWS environments or launch a virtual machine in Microsoft environment. So technically all of those services are available in the cloud. As you see, it's my browser. That's my browser as you see. And all of those services, storage, database, analytics, websites, storage, AI, they all are available inside your cloud account. Access control, setting Active Directory. Tomorrow we go to Windows Server and we see how an Active Directory may look like in reality in a physical server, but also Microsoft Azure have Active Directory in the cloud. In this environment, it's a shared responsibility as discussed. It means that you are responsible. I'm responsible to keep my credentials secure. I'm responsible for protecting my account, my password, connecting a multi-factor authenticator. And AWS is responsible for maintaining my access. AWS is responsible for providing security for this data center. They are responsible for creating backups. If something happened to the data center, I don't want to see that I have no access to my resources. So big businesses, they all are here. Imagine, for example, Netflix has all of their servers in AWS. What happens if AWS data center goes down for 1 week or even for 1 day? So if you try to watch some movies in Netflix, website is down. How much does it cost for that business? Billions of dollars. So we are responsible if we have part of our data. For example, if I get this 2 TB storage in Google Drive or Dropbox, it's my responsibility to make sure that I have correctly uploaded my files in this storage. It's my responsibility to renew my plan. Sometimes it happens that you have an account and you pay monthly, but you didn't renew your account. You didn't pay for the upcoming months. So they close your account. Obviously, they give you a warning that by, for example, this time your account will not be renewed because, for example, you cancel your subscriptions or whatever. So what happens? All of your data in that cloud space will disappear. It will be automatically deleted. So it's your fault. It's not the cloud provider fault. Cool. So that's all. As I said in set 4, if you go to set 4 IT or set 4 in cybersecurity, you will learn more about the cloud services in more detail. And let me to show you a final video. And in meantime that you are watching the video, I update the attendance. Ticketmaster didn't 3 days get a really nasty CV in 2016. Correct. Yes. Lean. Yes. In 2016. Yeah. All of those encryption, they may have some vulnerabilities, and eventually, as discussed, by improvement in the processing power, possible that a very trusted encryption algorithm get vulnerability. Drive home now. That's okay, Allah. Cool. Yeah, cool. So let me to show you this final video, and in the meantime, I update the attendance.
And how does it work? In the simplest terms, encryption means converting readable data into code. Why is encryption needed? Because cyber criminals want data so they can use it to steal or extort money from victims, or somehow use it against them. Data can be stolen when transferred across the internet, or when stored on a device. To prevent this, you can use encryption software or hardware to secure data. Not only is encryption the easiest way to secure data from being read or stolen, It is the foundation of data security. Here's how it works. Encryption uses a set of mathematical values called a cryptographic key or algorithm. It changes plain text data so that it appears as random, incomprehensible gibberish. This is known as ciphertext. The recipient of the ciphertext uses the key to decrypt the data, turning it back into readable plain text. The more complex the key, the more secure the encryption. Keys are classified according to the number of binary digits or bits they contain. Older algorithms use shorter keys, such as 64 bits. That means there are 2 to the 64th power possible combinations that must be tried to break the key. New, much stronger algorithms are developed as computers become more powerful, and cybercriminals spend less time cracking existing algorithms. The 2 most commonly used are 128-bit and 256-bit. Different algorithms are used depending on whether encryption must be fast and user-friendly, such as with a phone or computer, or for data that's highly confidential and not reliant upon speed, such as medical records. Different types of encryption are used depending on if the data is stored or transmitted. Symmetric encryption is ideal for stored data or data at rest. Symmetric means the same key is used to encode and decode. This is also known as private key encryption. Data is at rest when it sits on the storage device and is not being used or transferred. It should be encrypted to prevent theft through lost or stolen devices, password sharing, or permission granting. Symmetric encryption makes it harder for cybercriminals to access sensitive information. Asymmetric encryption is used for data in transit, or when it is transferred across the internet or into the cloud. Asymmetric means it uses a private key by the owner and a different public key shared with authorized users. This is also known as an end-to-end encryption. If the data is intercepted while in transit, asymmetric encryption ensures it is protected, because only the 2 users who possess keys can decrypt the conversation. You use encryption every day. If you have a password for a device or for online accounts, encryption scrambles your password so it's unreadable by cybercriminals. Your email is encrypted. So are your instant messages. A website with a padlock icon next to the URL or has an S in the HTTPS section of the address means it is encrypted. Hackers can't steal or alter data on the site or as it transfers to your device. When you purchase something online, encryption is used to protect the transaction data. Encryption helps organizations comply with regulations on data use and storage. It maintains privacy when moving data to and storing in the cloud. It guards data from theft or loss for employees who work from home through their company's private network, and it protects intellectual property from unauthorized use. For individuals who want to keep their private information private, or global corporations who must protect their assets, encryption is a daily necessity to keep data from being stolen or compromised. Kaspersky's virtual private network offers the encryption you need for secure and private network.
Cool. So that's